First item on the agenda for today is an information item provided with a 2015 Regulatory Oversight Report on the use of nuclear substances in Canada, is outlined in CMD 1637 and 16M37.A. The public was invited to comment in writing, and the Commission received one submission from the Canadian Radiation Protection Association, which are here with us in attendance, so we're going to hear from them later on. So we'll also provide them with an opportunity to make a short presentation. So over to CNSC staff, and I understand Mr. Moses, you will make the presentation. Over to you.
Merci, Monsieur le Président, membres de la Commission. Je m'appelle Colin Moses et je suis le directeur général responsable de la réglementation des substances nucléaires. Je vous présente mes collègues, Monsieur Sylvain Faye, directeur des autorisations de transport et du soutien stratégique, Madame Jacinthe Plante, directrice par intérim de la division des installations de catégorie 2 et des accélérateurs, Mr. Henry Rabsky, Director of Operations Inspection, and Mr. Peter Frunderick, Director of the Nuclear Substances and Radiation Device Licensing Division. On est également joint par d'autres membres du personnel de la CCSN qui sont présents dans la salle en appui à l'équipe. Nous vous présentons aujourd'hui le rapport annuel de surveillance réglementaire sur l'utilisation des substances nucléaires au Canada pour l'année 2015. Ce rapport constitue le 6e rapport produit jusqu'à maintenant par la CCSN. Le précédent rapport vous ayant été présenté en septembre 2015. Production of this Regulatory Oversight Report continues to be an achievement for the Canadian Nuclear Safety Commission and a mark of best practice internationally. The CNSC continues to be the only nuclear regulator in the world to be producing such a comprehensive report on regulatory oversight of the use of nuclear substances and equipment in industrial, medical, commercial, and research and academic settings. Following the presentation today, the report will be finalized and published on the CNSC external website. Before getting into the presentation, I would just like to note two small corrections to the report. First of all, in the appendix, and you don't need to turn there, but just to note that one event was reported twice in the list because it was reported to us both by the consignor and the consignees. So the total number of events in 2015 is actually 155 as opposed to 156. And the second is a minor editorial correction, but on page 39 at the top of the report in the English version, again, no need to turn there, but it reads currently that no other nuclear energy worker or member of the public was exposed to radiation, and we should complete that sentence within in excess of regulatory limits. The CNSC regulates the nuclear industry in Canada through a comprehensive program of licensing, certification, compliance verification, and enforcement. The safe use of nuclear substances in Canada is a reflection of licensees' compliance with the Nuclear Safety and Control Act, as well as its associated regulations and specific conditions set out in CNSC licenses. The Nuclear Safety and Control Act, its regulations, and the license require that licensees implement and maintain appropriate programs to ensure the safety of nuclear activities, minimize doses to workers and the public, and minimize any potential consequences of events. Licensees are always responsible for the safety of their operations and activities. For each nuclear industry sector described in this report, CNSC staff conduct inspections, assessments, and reviews to evaluate each licensee's programs, processes, and safety performance. Pursuant to the CNSC's mandate for the dissemination of objective regulatory information, and consistent with our commitment to transparency in all our activities, the CNSC publishes a series of annual regulatory oversight reports covering all main sectors of CNSC-regulated activities. You've already heard about the CNSC's regulation of nuclear power plants, and today we will be presenting the CNSC's Regulatory Oversight Report on the use of nuclear substances in Canada. On this slide, you'll see an overview of the presentation, providing an introduction of the CNSC's regulatory approach to regulating nuclear substances in Canada, and going on to present on the performance of each sector. We will continue the presentation, highlighting our progress on certain key initiatives underway in 2016. Moving on to the introduction. In 2015, the nuclear substances industry in Canada continues to operate safely. CNSC oversight activities, including licensing reviews, technical assessments, and inspections, confirm that licensees in the sector have appropriate safety programs in place in order to protect the health and safety of Canadians and the environment. Further, CNSC staff verified that licensees continue to maintain adequate measures to implement Canada's international obligations. Of the 155 reported events in 2015, one resulted in a worker exceeding regulatory dose limits for extremities, and we will discuss this event later in the presentation. The results of our review, documented in a 2015 Regulatory Oversight Report on the use of nuclear substances in Canada, confirmed that the use of nuclear substances in Canada is safe. For this year, the report includes more detailed information on CNSC activities related to the regulatory oversight of the nuclear substances industry. Most notably, the inclusion of reporting on performance of the results in the Management Systems Safety and Control area, and the inclusion of basic information on all events reported to the CNSC for this industry. In addition, the CNSC remains committed to improvement, and we discuss our continued efforts to simplify licensing through the consolidation of licenses for licensees holding multiple licenses, as well as providing additional information on the CNSC's certification of exposure device operators. Finally, as our reporting on industry performance across all regulatory sectors continues to expand, we have now transferred performance information on the 2 Class 1B accelerator facilities to the 2015 Nuclear Processing and Small Nuclear Reactor Research and Class 1B Accelerator Facilities report, where it is presented with other similarly classed facilities. For the second year, the CNSC posted our draft report for comment prior to presenting the report to the Commission. The report was posted on the CNSC's website and pushed out to subscribers to the CNSC's subscription service. In 2015, we updated this list to proactively add all DNSR licensees in order to ensure that they're being informed of regulatory developments at the CNSC. We regularly maintain this list to reflect any changes in the licensee population. In addition, we promoted the publication of the report for comment on the CNSC social media channels. The report was available on the CNSC website for 30-day comment period during the month of August 2016. New for this year, the CNSC also made participant funding available to support the review of the report. One application for funding was received, which was granted by the CNSC Funding Review Committee to the Canadian Radiation Protection Association. The submission by the CRPA was the only one received on this report. While we'd like to take this as a testament to the many improvements we've brought to the report over the years, as well as our comprehensive outreach program, we are somewhat disappointed that we did not receive additional input from licensees and other stakeholders. Submissions on our report have served as useful feedback to support the continuous improvement of our regulatory program. And as a result, we'll be looking at ways next year to promote engagement on this report. This slide and the next highlight the specific comments that were raised, and you will be hearing more about these directly from the CRPA. As noted, CNSC staff appreciate feedback on our regulatory program. This helps us assess the effectiveness and the efficiency of our regulatory processes and informs the prioritization of our improvement initiatives. In that regard, I'll note that many of the suggestions from CRPA are areas that we already had plans in place to assess. For example, with respect to reportable events, the annex included for the first time in this year's report is a first step in sharing operating experience across the industry, so that licensees can learn and improve from each other's experience. We fully support initiatives underway in the industry to share this kind of information proactively, such as the SHARE initiative, which is highlighted in CRPA's submission. CNSC staff appreciate the comments from the CRPA, as well as the other feedback that we receive from our stakeholders through the many outreach activities that we hold throughout the year. This is an important piece of our goal of maintaining a modern, effective, and efficient regulatory program. I'll now turn the presentation over to Mr. Peter Funderick.
Mr. President, members of the Commission, my name is Peter Funderick, and I'm Director of Nuclear Substances and Radiation Devices Licensing Division. In my part of the presentation, we'll provide an overview of the 4 main sectors that are covered by the report. In this presentation, detailed information will only be presented on the overall performance of the 4 main sectors. Further information on the performance of these sectors and the subsectors within each is available within the Regulatory Operations Report. The uses of nuclear substances and nuclear technology in Canada are broad and diverse. For reporting purposes, we have structured the report to cover the 4 main sectors of the applications of nuclear substances as follows. The medical sector, covering the uses of nuclear substances or technology for both diagnostic and therapeutic purposes. The industrial sector, addressing industrial uses of nuclear substances or technology in fabrication and production facilities or as part of fieldwork or construction activities. The academic and research sector, including the uses of nuclear substances or technology for research and teaching purposes. And the commercial sector, which includes licensees that produce, process, store, or distribute nuclear substances or offer other services for radiation devices. The medical sector consists of 494 licenses, which is approximately 21% of all the licenses issued. There are 10,704 total workers, which represent 20% of all workers involved in these nuclear activities. Approximately 70% of the nuclear workers in this sector are nuclear energy workers. There are 3 specific subsectors reviewed in the full report: diagnostic and therapeutic nuclear medicine, where nuclear substances are inhaled, ingested, or injected into patients, including for diagnosis, treatment, and research on humans. Radiotherapy, where radiation from nuclear substances, internal or external to the body, is used to treat disease. And veterinary nuclear medicine, where nuclear substances are used in a similar manner, but for animals for diagnosis and treatment of disease. This sector does not include information regarding administration of nuclear substances to animals for research activities. Research activities involving the administration of nuclear substances to animals is covered in the academic research sector, which will be discussed later. The industrial sector comprises 1,349 licenses, which is approximately 59% of all the licenses issued by the CNSC in this division, in this directorate. This also includes 32,323 workers, which represents approximately 60% of the workers using nuclear substances and prescribed equipment. Nuclear energy workers in this sector represent only 32% of all the workers in this sector. Many industrial applications do not require that all workers are considered as nuclear energy workers, only those with the potential to receive significant exposure. Safety performance results are provided in the full report for all licensees included in the industrial sector. The following 4 subsectors are highlighted in further detail. Portable nuclear gauges, which use gamma and neutron emitting sealed sources in smaller radiation devices to measure parameters most often associated with civil engineering, including density, compaction, thickness, and moisture content. Fixed nuclear gauges, where sealed sources in radiation devices monitor process flow in a pipe, storage tank levels, excuse me, or the density or thickness of material being manufactured. Industrial radiography, which uses gamma-emitting sealed sources in specialized radiation devices to provide field identification of welding defects, structural anomalies, and voids in cast material. And oil well logging, which lowers specialized gamma and neutron-emitting sealed sources contained in robust radiation devices into a drilled hole to map out the subsurface geological structures and characteristics. The academic and research sector involves the use of nuclear substances and prescribed equipment in teaching and research applications. Much of the work conducted by licensees in this sector involves biomedical teaching and research, but it also includes licensees who provide training services to other persons. As noted previously, administration of nuclear substances to animals for research purposes is included in this sector. The academic and research sector includes 207 licenses, representing 9% of all the licenses issued by the Directorate of Nuclear Substance Regulation. The total number of workers in this sector is 8,137, which represents 15% of all the workers using nuclear substances and prescribed equipment. And just over 35% of these workers are considered as nuclear energy workers. The subsectors in this group include laboratory studies, which primarily involve the use of unsealed nuclear substances, mostly for academic and biomedical research. Also included are consolidated uses of nuclear substances, which are complex licensees at institutions such as hospitals and universities, where the licensee has a substantial program in place and administers an internal system of permit approvals. The commercial sector includes 246 licenses, which represents approximately 11% of the licenses issued. In this sector, there are a total of 2,536 workers, which represents only 5% of the workers involved in the use of nuclear substances and prescribed equipment. Of these workers, almost 74% are considered nuclear energy workers. Safety performance results are provided for all licensees included in the commercial sector, and the following 5 subsectors are highlighted in further detail. Production of short-lived medical isotopes in accelerators and cyclotrons, and the processing of those supplies for distribution to other licensed locations. The processing of nuclear substances, typically for nuclear medicine, to match demand for medical isotopes more closely to the supply. Distribution of nuclear substances and prescribed equipment, generally from manufacturers and suppliers outside of Canada or within Canada. Servicing of prescribed equipment following specific CNSC-approved procedures to ensure safety for all persons. And the calibration of radiation detection equipment, where the possession of the equipment to conduct the calibration requires CNSC authorization. As illustrated in this slide, our oversight of the safe use of nuclear substances covers activities across all provinces and territories of Canada. This includes all major hospitals in Canada, most Canadian universities and research institutions, a wide variety of industrial manufacturing and production facilities, and all locations that store, produce, service nuclear substances and radiation devices. In addition, our regulatory oversight extends to field uses of nuclear devices, and our compliance approach, which we will be outlining later, includes field inspections to ensure that nuclear devices are being used in a safe and secure manner across the country. As of December 31st, 2015, there were 2,295 active CNSC licenses held by 1,599 licensees. The extent of activities in these areas remain relatively stable, and despite normal variations in individual businesses, the total number of licensees has remained relatively stable over the past 5 years. You will note, however, a small decrease in the number of individual licenses from last year as compared to 2014, where there was 2,411 active licenses held by 1,702 licensees. This was primarily driven by the development of a license consolidation strategy aimed at reducing administrative burden on organizations that hold multiple licenses for various licensed activities, such as hospitals and universities. Consolidation of Class II nuclear facility licenses has allowed, for example, the CNSC to authorize a hospital with a medical linear accelerator to operate and service the accelerator under one license instead of 2. In addition, many provincial medical institutions are amalgamating under larger regional groupings as part of a provincial healthcare restructuring plan. As can be seen from this slide, the majority of workers involved in the use of nuclear substances and prescribed equipment arise in the industrial sector, which represents 60% of all workers. The smallest proportion of workers at just 5% is in the commercial sector. The medical sector represents 20% of all workers, while the academic and research sector contributes approximately 15% of the workers. As noted, this represents all workers monitored for radiation doses in the 4 sectors. Pursuant to the Nuclear Safety and Control Act, doses are monitored for all workers involved in activities authorized by the Commission. In 2015, there were a total of 53,700 persons working in the fields covered by this report, approximately 60% of those working in the industrial sector, consistent with the relative distribution of our licensees. Of the total number of workers, 41.5% were designated as nuclear energy workers. Nuclear energy workers are those who, in the course of their business or occupation, in connection with a nuclear substance or nuclear facility, perform duties in circumstances which may result in receiving a dose of radiation greater than 1 millisievert per year. The CNSC staff effort related to licensing and certification and compliance verification represents just over 13,000 person days. The majority of the staff involved in licensing, certification, and compliance verification are located in Ottawa, although, as noted, some licensing and most compliance verification staff are located in regional offices. The amount of CNSC staff effort includes administrative support and other CNSC specialists that are necessary to ensure an effective and efficient regulatory program. CNSC staff in regional offices conducted 1,144 inspections in 2015, while the remaining 424 inspections were conducted by staff from the main office in Ottawa. Designated officers in the CNSC Directorate of Nuclear Substance Regulation and the Directorate of Safety Management made a total of 2,579 licensing and certification decisions in 2015, over 80% of these being licensing decisions. Designated officer decisions are based on a comprehensive evaluation of licensing requests by CNSC staff, which are then peer-reviewed to ensure that the recommendation is well supported and that all regulatory requirements have been met. The designated officer makes a decision on each licensing action to ensure that it meets the requirements of the Nuclear Safety Control Act and the regulations. CNSC staff continue to meet all business standards for processing of license applications. In addition, licensing requests that involve patient care are immediately flagged as a priority and are completed within 24 hours, usually within the same day. I will now turn the presentation over to Mr. Henry Rapsky.
Henry Rapsky, for the record, Director of Operations Inspection Division. To ensure comprehensive regulatory oversight and reporting, compliance requirements have been categorized into a well-established set of 14 technical areas that have proven effective in evaluating licensee performance. These are known as Safety and Control Areas, or SCAs. For the purposes of this report, licensee performance in the 4 nuclear sectors are measured by examining the licensee's regulatory compliance in 4 selected SCAs, those being Management System, Operating Performance, Radiation Protection, and Security. CNSC staff routinely review applications and perform technical assessments to take licensing actions or for the certification of radiation devices and prescribed equipment. The purposes of these reviews and technical assessments is to determine if the applicant is able to meet all applicable CNSC regulatory requirements and has put adequate measures into place to ensure the protection of the environment and the health and safety and security of persons. The accelerators and Class II facilities, along with nuclear substances and radiation devices licensing divisions, have developed a license consolidation strategy to reduce the administrative burden on organizations which hold multiple licenses for CNSC regulated activities. Approximately 1 million packages containing nuclear substances are safely transported each year across Canada. The packaging and transport of nuclear substances is jointly regulated by the CNSC and Transport Canada. Packages that are used for the transport of nuclear substance must comply with the CNSC packaging and transport of nuclear substance regulations, Transport Canada's Transportation of Dangerous Goods regulation, and the International Atomic Energy Agency's regulations for the safe transport of radioactive material. In June 2015, the Packaging and Transport of Nuclear Substance Regulations 2015 were published in the Canada Gazette Part 2. These revised regulations align to the IAEA regulations and ensure continued alignment by including an ambulatory reference. The new regulations provide additional clarity in the areas of radiation protection program requirements, reporting requirements, the transportation of large objects, and the discovery of material containing unidentified nuclear substances. In addition, a new CNSC document, Reg Doc 214.1, Packaging and Transport, was published in February 2016, which links the provisions of the packaging and transport of nuclear substance regulations to specific relevant content in IAEA regulations, the Nuclear Safety and Control Act, and other CNSC regulations. In 2015, CNSC staff conducted 1,568 inspections across the 4 sectors. These inspections verified compliance with all applicable safety control areas. A risk-informed decision process was used for the planning and conducting our compliance activities, commensurate with the risk associated with the various uses of nuclear substances within those sectors and facilities. CNSC staff also verified compliance through desktop reviews of licensee annual compliance reports, license applications, and licensee program documents. CNSC staff require licensees that have failed to meet regulatory requirements to take corrective measures to address non-compliances identified during inspections. Any non-compliances identified are systematically tracked by the CNSC staff to ensure that licensees have taken satisfactory corrective measures. Inspections are conducted by CNSC inspectors at defined frequencies, determined by the risk of the licensed activities. Activities which have been evaluated as being high risk are inspected more frequently than those which have been evaluated as lower risk. Inspection planning is conducted on an annual basis and takes into account these defined inspection frequency as well as the licensee's compliance history. Inspections plans are reviewed throughout the year and adjusted as necessary to take into account poor licensee performance or new information, such as events that have occurred and or changes reported by the licensee to the CNSC staff. Inspections which are planned but may not be performed are systematically tracked to be included in future inspection plans. When CNSC staff identifies that a licensee is in non-compliance with a regulatory requirement, a graded approach is applied to encourage and bring the licensee back into compliance, as well as to deter future non-compliances. The risk and safety significance of each non-compliance is considered when determining the appropriate enforcement action to be taken. As the risk and safety significance of the non-compliance increases, the chosen enforcement action will become more escalated. Examples of enforcement actions used to address non-compliances range from written notices requiring corrective measures to be implemented to inspector orders ceasing unsafe activities that put workers and the public at risk. A key component of each licensee's radiation safety program is the Radiation Safety Officer, or RSO for short. The RSO has the primary responsibility for the licensee's radiation safety program to ensure that the licensed activities are conducted safely and all regulatory expectations are met. More specifically, they're required to maintain management oversight over the radiation safety program and implement things such as personal qualification and training programs, control of occupational and public exposure to radiation, planning for unusual situation and emergencies, measures to prevent workers from receiving doses of radiation higher than the dose limits prescribed in the regulations. All licensees that operate Class 2 nuclear facilities or that service Class 2 prescribed equipment must have a certified radiation safety officer and a qualified temporary replacement. If the candidate is unable to clearly demonstrate through an interview process to the CNSC their knowledge, CNSC knowledge, as it relates to the position within their organization, the Commission or a designated officer authorized by the Commission may certify the candidate in the position of the Radiation Safety Officer. In 2015, the CNSC certified 17 Class 2 RSOs. The appointment of radiation safety officers for other licensees does not involve a certification process. However, for high-risk activities, CNSC staff interview prospective RSOs during a pre-licensing visit to verify their knowledge of the company's radiation safety program, and to confirm their understanding of their obligations as a licensee. RSOs for new, low, and medium risk licenses are expected to attend third-party radiation safety officer training to ensure these individuals understand the additional responsibilities placed on that position. In any case, if it is deemed that the appointed RSO does not have adequate knowledge, the licensing decision may be delayed until the appointment of a suitable representative can be made. Industrial radiography involves the use of nuclear substances and exposure devices for the non-destructive examination of materials. Licensees are required under the Nuclear Substances and Radiation Devices Regulation to only permit CNSC certified personnel and supervised trainees to use exposure devices. As of September 1st, 2016, there were 2,429 certified exposure device operators in Canada in possession of a valid certificate with an expiry date. The CNSC Exposure Device Operator Certification Program is designed to ensure the continued competency of the operator and maintaining the safety and security of persons and devices when working with exposure devices. Since implementation of the Canadian Standards Association Certified Exposure Device Operator Personnel Certification Guide, and we call that the CSA PCP 09 for short, in 2015, the CNSC now requires certified exposure device operators to renew their certification every 5 years. This requirement to renew their certification ensures that every exposure device operator maintains the knowledge and skills required to safely operate an exposure device. In 2015, the CNSC certified 141 new exposure device operators and renewed the certification of 240. The CNSC may take regulatory action up to decertification or prosecution if the exposure device operator is found to be operating contrary to safety protocols Stakeholder engagement in the form of outreach remains integral to the CNSC's objectives. CNSC staff believe that increased awareness and better understanding of the regulatory requirements by licensees and other persons regulated by the CNSC leads to increased safety in the workplace. Improvements in workplace safety have been observed in subsectors that the CNSC staff have targeted with focused stakeholder engagement activities. Since 2009, the CNSC has conducted a formal outreach program for licensees that use nuclear substances. This program of presentations by CNSC staff and open discussions groups inform stakeholders on upcoming and recent regulatory changes and provides education regarding the CNSC's expectation for licensing and compliance requirements. In 2015, the CNSC continued to create more opportunities for licensees and other persons to interact with the CNSC staff outside the scope of routine inspections and licensing activities, these including the portable gauge industry within the industrial sector. The CNSC introduced a financial guarantee program for all nuclear substance licensees in 2015. The purpose of this new program is to ensure that sufficient financial resources are available to safely terminate a licensee's activities should they become unable to do so. This is the first time that a financial guarantee program for nuclear substances has been implemented. The requirement for licensees to maintain a financial guarantee came into effect on April 1st, 2015, and all licensees were in compliance for the year 2015. The CNSC introduced new regulatory requirements contained within Reg Doc 212.3 for licensees in possession of high-risk Category 1 and 2 sealed sources in May 2015. Following this implementation date, CNSC inspectors began conducting enhanced security inspections to verify compliance with these new regulatory requirements. Compliance with new security requirements for licensees with high-risk sealed sources was satisfactory in 2015. Of the 250 inspected licensees, 168, or 77.4%, were found to be compliant with these new requirements. CNSC staff ensured that the 49 instances of non-compliances identified were adequately corrected by licensees. The majority of non-compliances identified were related to administrative requirements, such as record keeping, which did not directly impact the security of the sealed sources. The new regulatory requirements within Reg Doc 212.3 will become applicable to licensees with medium and low risk Category 3, 4, and 5 sealed sources in May 2018. These new requirements are in addition to current regulatory requirements. CNSC staff are developing a strategy to promote these new regulatory requirements to these licensees in advance of the implementation date. At this time, I would now like to turn the presentation over to Sylvain Fay, Director of Transport Licensing and Strategic Support Division.
Merci, Henry. Bonjour, Monsieur le Président et membres de la Commission. Through the following slides, I will be providing an overview of the safety performance of nuclear substances licensees for 2015. Overall, licensees continue to demonstrate adequate performance within the safety and control areas. The majority of inspected licensees in 2015 were found to be compliant in the 4 SCAs covered in this report, namely management system, operating performance, radiation protection, and security. More details on these 4 safety and control areas is provided in the following slides. The reporting on the safety performance of licensees with regards to management system is new for 2015. Management systems, which covers the framework that establishes the processes and program required to ensure that an organization achieves its safety objectives, continuously monitors its performance against those objectives, and foster a healthy safety culture. Overall, 96.2% of all inspected licensees showed a satisfactory rating for the safety and control area. The majority of non-compliances included conducting the activities contrary to a license, failure to comply with regulatory requirements related to having records at work locations, and failure to notify the CNSC of changes in contact for licensed activity. For licensees such as hospitals that holds multiple licenses for various activities, non-compliances observed during inspections mostly related to inadequate management oversight of their radiation protection program. In all cases, licensees addressed these non-compliances to the satisfaction of the CNSC. Moving forward, the results from subsequent years will be added and trending will be monitored as part of the report, similar to the other safety and control areas. Moving now to operating performance, which refers to the licensee's ability to perform licensed activities in accordance with pertinent operational and safety requirements defined in the Nuclear Safety and Control Act, its associated regulations, and license conditions. Licensees are expected to demonstrate that they comply with operational and safety requirements by providing workers with appropriate procedures for the safe use of nuclear substances and prescribed equipment, by ensuring that workers follow procedures, and by maintaining records that demonstrate compliance. All sectors continue to demonstrate adequate performance in 2015, with 90.6% of inspected licensees found to be in compliance with regulatory requirements. The majority of non-compliances in the safety and control area included failure to comply with regulatory requirements related to retention of records, workers' obligations, and seal source leak testing. In all cases, licensees addressed these non-compliances to the satisfaction of the CNSC. As shown in the table, 2 inspections conducted within the industrial sector resulted in an unacceptable rating for the safety and control area in 2015. In both cases, an order was issued to ensure that corrective actions were taken immediately. Despite stability in the overall industry, the academic and research sector rating in this safety and control area has been trending downwards since 2013. In response to this trend, CNSC staff modified a component of their outreach strategy to increase the focus on this industry sector in 2016. Moving now to radiation protection, which requires licensees to establish programs to ensure that contamination levels and radiation doses received by workers are monitored, controlled, and maintained below regulatory dose limits, and kept at levels that are as low as reasonably achievable, social and economic factors being taken into account. Licensees are expected to monitor worker dose, post radiation warning signs, plan appropriately for radiological emergencies, manage oversights of operational activities, institute effective workplace practices that emphasize the use of time, distance, and shielding to minimize exposures to radiation, and use appropriate protective equipment. All sectors demonstrated a good performance within the safety and control area, with 88.7% of inspected licensees who received a satisfactory rating. The majority of non-compliances included survey meters not being calibrated, inadequate implementation of measures to ensure that doses are kept ALARA, and improper posting of signs at boundaries and point of access. In all cases, licensees addressed these non-compliances to the satisfaction of the CNSC. As it can be seen, this safety and control area has remained relatively stable over the years and showing a small increase in the overall compliance rating since 2013. And finally, security, which requires licensees to have in place physical security measures, practices, and programs to prevent the loss, illegal use, illegal possession, or illegal removal of nuclear substances during the entire life cycle, including while they are in storage or during transport. The extent of the security measures required depends on the type of nuclear substances used and activities performed by each licensee. All sectors showed satisfactory rating for the safety and control area in 2015, with 95% of inspected licensees found to be compliant with regulatory requirements. 2 inspections were given an unacceptable rating and resulted in the issuance of an order to each licensee to ensure that corrective actions were taken immediately. Licensees addressed and corrected all non-compliances identified during inspections to the satisfaction of CNSC. The performance in the safety and control area remained stable in comparison to last year, which was the first year where the safety performance of licensees for the safety and control area was incorporated into the report. To address non-compliances, CNSC staff used a variety of enforcement actions. These range from notifications of non-compliances up to requiring corrective actions through the issuance of inspector orders or imposing administrative monetary penalties. The nature of the enforcement action is based on the seriousness of the non-compliance as well as case-specific circumstances. Depending on the severity of the non-compliance, more than one enforcement action could be needed. In 2015, the CNSC escalated compliance enforcement action in 21 instances for licensees in the medical, industrial, academic and research, and commercial sectors. In 15 instances, the CNSC staff issued orders which required licensees to take immediate corrective measures. In each case, the licensee immediately complied with the order. Once the CNSC was satisfied that the licensee had addressed the order's terms and conditions, the order was closed. As well, CNSC designated officer issued 6 administrative monetary penalties in 2015, and all administrative monetary penalty issued in 2015 have been paid. Although not shown on this slide, the CNSC decertified 1 exposure device operator in 2015. This stemmed from an inspection in 2014 that identified non-compliances relating to the use of survey meters and supervision of exposure device operator trainee. Licensees are required to have programs in place for the management of unplanned events and accidents. The situations that warrant mandatory reporting and the content of the reports are set out in legislations, regulations, and condition of their license. CNSC staff review, assess, and track all events reported by licensees. For the second time this year, reported events have been ranked using the International Nuclear and Radiological Event Scale, INES, a tool for communicating the safety significance of nuclear and radiological events to the public. As described last year, this tool allows the establishment of a perspective of an event safety significant. The scale has been used to classify events at nuclear power plants since 1990 and has been extended over the years to apply to all nuclear industry installation. By 2006, it had been adapted to all events associated with the transport, storage, and use of radioactive sources and nuclear substances. Note that the scale is not a tool to compare safety performance amongst facilities or organizations, but to effectively communicate the safety significance of events. In 2015, there were 155 events related to nuclear substances reported by to the CNSC by licensees in the sectors covered in this report. Events involving missing or found sealed sources are also incorporated into a report that is available on the CNSC website and updated on a regular basis. Of the 155 events, 147 were ranked as level 0 or of no safety significance under the INES scale. 6 were ranked as level 1 or anomaly on the INES scale due to the quantity of nuclear substances involved and the type of event reported. Finally, 1 ranked as level 2 or incident under the INES scale. More information on these events which obtain an INES rating above 0 is provided in the next slides. There were 6 events reported that received a level 1 rating under the INES scale. Of these events, 5 involved the loss of portable gauges containing low risk, category 4, sealed sources. The figure on the right side of the slide demonstrates that the above noted event correspond to a level 1 on the INES scale. Events where portable gauge have not been recovered continue to be tracked by CNSC staff. The remaining event involved a nuclear medicine worker who self-administered iodine-123 for thyroid procedures on 2 occasions. This event was reported by the licensee in 2015 when they became aware as these events occurred in previous years. The level 2 event occurred when a nuclear energy worker from the commercial sector received an extremity dose above the regulatory limit of 500 millisievert for the end. The worker in question, who was processing fluoride 18 in a hot cell, handled a large quantity of this radioisotope without shielding. As a result, the worker was exposed to a relatively high extremity dose. The dose to the worker's left hand was conservatively estimated by CNSC staff to be 1.7 sievert, which is above the annual regulatory limit for extremities, but below the threshold for deterministic effects. The effective dose to the worker was estimated to be 15 millisievert as a result of this event. No other nuclear energy worker or members of the public were exposed to radiation. Under the INES scale, this event ranked as level 2 or incident since the exposure to the worker exceeded 10 millisievert. Such doses are well below the regulatory dose limit for nuclear energy workers and would not be expected to result in adverse health effects to the exposed person. In response to this situation, the licensee removed the worker from duties associated with nuclear substances in accordance with the radiation protection regulations. And CNSC staff conducted an inspection as part of the review and assessment of the event. As a result of the inspection, the CNSC issued an order to the licensee. This event was presented at the June 2015 Commission meeting and is considered closed. Overall, doses received by nuclear energy workers remained low in 2015. While the regulatory dose limit is 50 millisievert per year, the majority of workers received a dose below 1 millisievert, which is the dose limit for members of the public. In 2015, no nuclear energy workers exceeded the 1 or 5-year dose limit of 50 millisievert and 100 millisievert respectively. I will now turn the presentation over to Mr. Colin Moses.
Thank you. Before staff conclude the presentation, we would like to provide an update on some of the industry trends that we continue to monitor and to highlight some of the work that we currently have underway in 2016. As is evidenced by this report, the nuclear substances industry is a diverse and ever-changing community. As a result, CNSC staff monitor trends and developments in order to ensure that we maintain a program that is suitable and effective and reflects the current state of the industry. In recent years, a number of sectors have been trending towards consolidated operations. For example, in the medical sector, some provinces, including Alberta and Quebec, are revising provincial authorities to amalgamate hospitals by regions. Similarly, in the industrial sector, we are seeing larger pan-national companies acquiring smaller local companies. The recent downturn in the oil and gas sector has also had a significant impact on the industrial sector, particularly for the radiography and well logging industries which serve this sector. In addition, the nuclear industry is seeing an increased pace of change, particularly in the medical sector. Innovations in isotope production technologies are leading to a more diversified and decentralized supply of medical isotopes. CNSC staff are closely monitoring these trends to ensure we continue to have the necessary tools, requirements, and resources to effectively effectively oversee the nuclear substances industry. As necessary, we adapt our regulatory oversight strategies to ensure that licensees continue to maintain a high level of safety across all their operations. Some of the specific initiatives we have underway are discussed in the following slides. As I mentioned, staff are committed to maintaining a modern, responsive, effective, and efficient program. To that end, we are continuously seeking ways to improve based on feedback from our stakeholders, in response to trends identified in the industry, or as a result of lessons learned exercises that we perform following every major initiative. In 2016, we conducted a lean assessment of the nuclear substances and radiation devices licensing process. This 3-day workshop brought together experts of all groups involved in the activity, using a methodology that was originally developed for process improvement in the manufacturing sector. The workshop identified a number of opportunities to improve our internal processes, which we are in the process of implementing. Similarly, to simplify licensing and reduce administrative burden for licensees, we continue on our drive to offer consolidated licenses. We have made good progress for Class 2 facilities and are now turning our attention to nuclear substance and radiation device licenses, which will include a review of the license structure and processes to pave the way for this improvement for all licensees. With respect to radiation safety officers, we are undertaking an assessment of our oversight approach for those responsible for nuclear substances and radiation devices, in order to assess potential improvements to our program to ensure that they provide effective oversight of their radiation safety programs. Continuing to leverage best practices for compliance, we are increasingly making use of performance-based inspections so that we verify compliance with procedures while the devices are in use in the field. This is an important component of our portable gauge strategy, which drove significant improvement in the subsector over the past couple of years. Finally, to ensure that we continue to have a robust and defensible and efficient program, CNSC staff transferred the compliance oversight of the import and export of sealed sources to the Directorate of Nuclear Substances Regulation, leveraging our Directorate's existing compliance activities. As you heard yesterday, CNSC staff are also working on developing a number of regulatory documents that are relevant to this sector, including developing guidance on reporting expectations, as well as working on a reg doc that provides information on safety culture. This latter document outlines elements of a healthy safety culture and will serve as useful guidance for nuclear substance licensees. Coincident with this document, CNSC staff is developing a methodology to assess the maturity of a licensee's safety culture, and we'll be piloting this approach in the isotope production sector in the near future. In conclusion, both as a result of our rigorous licensing and certification reviews and our comprehensive and risk-informed compliance approach, and as evidenced by the continued low levels of exposure across the industry, CNSC staff conclude that the use of nuclear substances is safe, with adequate protection for the health and safety of persons and due consideration to the security of nuclear substances and prescribed equipment. Thank you for the opportunity to present this report, and we remain available to answer any questions you may have.
Thank you.